Hello and welcome to this new tutorial on Emgu CV, and today I am going to show you how we can perform digit recognition using support vector machine in Emgu CV. So let's get started. I have created a project and configured it to use Emgu CV 3.3. If you are not sure how to do it, you can check one of my previous videos. Right click on the project name, click on add and click on Windows Form. Give it a name, digit recognition SVM, and click on add. Since it will be a simple GUI, so let me quickly design this. So I designed a very simple user interface. It consists of load data to read the data, test and train data from the file which I have downloaded over here. So I have the test and the train data separately available. I downloaded this data from Kaggle website. I'll share this URL with you as well. So we have the test and the train data. One thing that I did with this train data is I just removed some of the training data, and I have only 10,000 samples for training and 10,000 for testing. So you can try with the other. Each row represents a simple sample. The first column is basically the label, and the rest of 784 columns in this first sample are representing the digit 5, and we can display this sample by reshaping it into a 28 by 28 image, which I have shown in this user interface. So I will display some of these labels of these digits, and then we will use the train and the test to train the SVM, and then we test on the test data. So let's first implement this load data. The first thing that I need is to create few variables that I need in the program. I declare the path for training data from where I need to load it. I have this training data over here at train.csv, train.csv. This is for training data. I will just use this Control C, Control V, and then I call it test data path. And you optionally need to put at the rate to make it like to use it as a normal string. And this is the test.csv file. So this is the test. So to use this Emgu CV, first I need to use emgu.cv and using emgu.cv.structure. And since I am using the support vector machine classifier, so I need to import one more namespace, that is emgu.cv.ml. Now I can create a few matrices which will hold the training testing data and also their corresponding labels. So let me do that. Create float. I'll create a float and call it train data, and also matrix of float to hold the test data, so I call it test data, and another matrix of integers to hold the train labels, and another matrix that is of type int to maintain the test labels. And now I will create the SVM, so I just call it SVM, and also I need a counter to keep information about the number of labels or the number of data that has been processed as yet. One more thing that I need is display image equals false. Just if it is set to true, then we will be able to see the train or test data in the form of an image. So let me go and load the test data. I will use the try and catch blocks. So if there is any error, then I'll show that error in it. And to load the data, let me create a private function, load train data. This will load the training data into my train data matrix, and similarly another function will be similar to it and load test data. I'll call this load train data from within this load menu, and also the load test data first. It doesn't matter whichever you need, you just need to load the train and test data into the matrices, these matrices. So let's go and implement this load training. I'll create a list of floats, and it is an array, and I call it train list equals new train list. Why I am creating a train list of type float and it is an array? I have this each sample is present in these rows, and I want to read each row, and this array means the list will contain a row of floats, so that the samples will be read one by one and put into this array, and the list will maintain the array of all these rows into it. Now I need to separate the first label and the rest of the data, so I need to create another list. I just Control C, Control V, and since we have declared these labels to be of type int, so you can use int, and this is train label, and this one should be of type int. So since this one is just each line will contain a simple label. The next thing that I want to do is to read this, open this file and read it, and to do that I need a stream reader. To use this stream reader, we need the namespace using system.io, so it has added over here, and I call it reader equals to new stream reader, and here I can pass the path of the string. Which stream I want to read is this training data path, so that I want to read it line by line. I just declare a string, I call it line, and set it to null string, so that I will read one by one from the text file and then separate the label and put it in train label and data into train list. So I need to do it in a for loop. First thing, I want to make sure that if file dot exists, that the file exists. If it does not exist, then it should throw an error, that is training data path. If it does not exist, then we can throw an error, new exception, and I can say that file not found. If it is found, then we need to loop through the file and read one by one. So while, we will define a while loop, and over here what we need to do is we declare this line equals to reader dot read line, and this will read line one by one, and if it is not equal to null, here is one missing, then we will proceed the loop, read this data. As we know that the first one is the label, and so I will try to find the index of the first comma, and whatever I have before that I will copy that information and put it in my training label. So integer first index equals line dot index of, I'm trying to find the index of comma, so wherever it will find the first comma, it will return me the index of that. Then I'll be able to separate the data till this first index using the function that is called substring. I'm going to start from the 0th string and give me all the strings till this index. And since I need this information to be a type of integer to put it in this train label, so I need to convert it into an integer, convert dot to int 32, and I just put it in an integer of type value, for example, or instead of saying value I should say current label. And once I separate the current label, the rest of it is data, so I just call it string current data equals line dot substring. Now I want the substring from where this first index plus 1 means after that comma plus 1. So what it will do, this substring, it requires a first, the starting index, I provided the first index plus 1 means after the first comma whatever I have, it put it into my current data. Now the trickiest thing right here is since this is a string and I need to convert it into a float and into an array, so here I will use the link query to convert this string, separate it first using the comma, and then convert it into a float and a float array and put it in this training list. So I create a float array, call it data equals current data dot split based on comma dot select. Now here what I am doing, x lambda expression, convert it into float dot parse x and dot to array. What it is doing is on every element that I have in after converting it into, after splitting it, every element x I first use the float dot parse to convert it into a float, and then whatever the result it returned to me, I convert it into an array and put it into a float. So this will read the whole data about the digit, and since we have separated the label over here, and the rest of the data is over here. Now we can add the current label into training label and this data into train list. So train list dot add is data, and train label dot add into current label. So this will go through the whole file and add all of the data into train list and all of the labels into train label. Now once we read the files, I created, as you know, this matrix train data, train label, test data, and a test label. Now I need this data to be in this format. However, if you look over here, the data over here is in an array format. So it is basically giving me, it is an array of floats and it is a list. It means it contains, it's a sort of a Jade array. This Jade array cannot be converted into a matrix, so I need to create a function to convert the data that is in the form of a Jade array into a 2D array so that I can put it in this train data and a test data. So I have created a function, and I'll just copy and paste here and let you know what it is doing. So let me create that function. I have copied it and pasted it over here. Basically this is the function that I have copied from this Stack Overflow. You can check it. What it is doing, I'll tell you. It will take as input a Jade array of any type. T means any type. It can be float, integer, so you can use it for anything. What it is simply doing is it is looping through the first and the second dimension, that is how many elements we have over here and how many elements over there, and it just creates a simple two-dimensional result array. You can see dimension first and the second dimension, and then it results as a simple 2D array. So I'll be calling that to 2D function to convert this Jade array into 2D array. So let me create train data equals new matrix, but it requires, as you know, a 2D data. So what I need to do is to 2D, I'll call this function of type float, and inside that I need to pass this train list dot to array. I'll pass this array. What it will do is it will be converted into this train list into a 2D array, as you can see, and then it will be initialized into train data. Similarly for train label, and remember that as this is a simple 1D array, we don't need to, even it can accept it of type integer, we don't need to convert it. It's not a Jade array, so I will just pass train label, and that's it. So till now, and of course I made a mistake here. It should be like a train label. One thing that I am pretty sure here is it should be a train label, and over here small with train label dot to array. So till here what we did is in this load train data, we load the train data into this train data and its corresponding labels into train label. So we can repeat the same process for the test data as well. I'll just copy this one, paste it right over here, and instead of using the train data path, I call it test data path, and right over here I need to change this test data and this one is test data test label. So once we read these test data and the train data, we can display a message here, message box, data loaded. And once we load the data, then we will be able to train the SVM. But before that, if you want to see some data over here, maybe I can add some more buttons, 2 simple buttons. This is for in this direction, copy and paste, and maybe this one for the other direction. I can click it. If train data is not equals null, then I should do nothing, return it. And I can show the train data over here. The first thing that I need to do is I declared a counter over here just to maintain where I am right now. Counter is less than train data the rows -1, then I can add the counter by +1. Now I will add a condition if counter is less than, I don't need this condition. If it is less, I will increase the counter. Now to show which digit is there, I need to convert that raw into an image. So I create an image simple of gray, of type gray, and a byte, and I call it Emg out. And what I need to do is train data dot get raw, which raw I want to get, current raw at the counter, and then I need to convert it into a mate object, and this one to an image gray byte. It is not necessary that I need to convert it, but what I want to do over here is to apply this binary threshold binary, and I set its gray value to be 50, for example, or 30, and the maximum value that I want is 255, so that I can see this this image clearly. And once I convert it, and also one thing that I need to do is before thresholding, it is this one is giving me a simple 1 by 784 raw, and I need to convert it into, reshape it first. Number of channels will remain 0, and the number of rows that I need 28. So if it is divided into 28, then it will adjust the columns accordingly. This is very important. And now PictureBox 1.image equals to Emgout.bitmap. This is the functionality when I click the backward button, and maybe I did it the reverse. Should be minus. If it is greater than 0, I will not see the first image, it doesn't matter. And for the forward, we can do the same thing, and here train data dot rows -1, and here I do ++. Then maybe I can put the check over here, and then maybe equal to